So I'm Gustavo Padovan. I work for Collabora as a software engineer. I'm also one of the maintainers of the Bluetooth subsystem, the Linux kernel. And I'm going to talk today about using BlueZ in the automotive world. First, just a basic overview of Bluetooth. I think most of people know about Bluetooth. It's like a radio technology that uses the 2.4 gigahertz band. It's designed like a cable replacement, like 20 years ago, I think. Used for short distances. And there is a okay. So 10 years ago, when they introduced the simple pairing and other new features, and it's specified by the Bluetooth Special Interest Group, which is built by many big companies like Intel and Microsoft, and Toshiba, Samsung, I don't remember all of them, Lenovo. It's low power, low cost. And then BlueZ. BlueZ is the official Linux Bluetooth stack. It has been this since 2001 when Qualcomm introduced the code the first time, the Linux kernel. I think it was 2.4 something, 2.4.6. Yeah. And BlueZ itself is not like planned for the final user. We provided the BUZZ API for those who want to use Bluetooth features in Linux. And we are using in most of Linux desktop, and we are on Android until 4.1. And Tizen, TonTon, and many other devices. Some of the BlueZ features that we have is like a completely modular implementation, and most of the things in BlueZ are implemented through plugins, so it's really easy to enable, disable, or implement new stuff, new profiles, support to new stuff. And we have like real hard abstraction. So you just plug a new device, new Bluetooth device, it sure will work. Otherwise, we just need to add some device IDs or some small quirks, and everything will work. We have like a standard sock interface, 12 layers. That's pretty easy to use, but of course we recommend you to use the Bluetooth daemon on the user space. And recently we added a new interface to control the Bluetooth device. It's called the management interface. It's an in-kernel code that handles our Bluetooth device. We used to do this in user space, like through raw sockets, but it wasn't the most optimized thing we had. And now we are doing this through this management interface. And BlueZ also has a very simple BUZZ API, and it's pretty straightforward to use. One of the pieces that BlueZ interacts is Ophono. It's an open source telephony stack. It's a few feature telephony stack, works with most of the modems out there. It's really nice. The support for when it calls multiple modem, like throughway calling and everything, SMS. It has an AT chat library internally. And other pieces common with Daniel and Marcel are talking here today. Common is like focused on mobile, has support to Ethernet, Wi-Fi, Bluetooth, mobile data, and VPN. We do tethering for Wi-Fi and Bluetooth there as well, and the Session API, which was the focus of their talk here. And the other piece that BlueZ uses a lot, it's Pulse Audio. All profiles that handles audio goes through Pulse Audio. That's used in like everywhere in Linux systems. And what I really want to talk is what's the state for each profile that the automotive world is going to use. The most important one are the first, like HTTP, AVRCP, HFP, and maybe PBAP, I think is the most important ones. So the first one is A2DP as a profile for high quality audio. Uh, in Bluetooth, you have like the concept of holes. So there is one hole in A2DP that's the source who provides audio to the other side, and the other side is the sync hole. In the automotive world, we are mostly interested in the sync hole, and BlueZ has support to it up to the version 1.2, but the 1.2 version is like just some small change, and we can support this like very quick, very easy. Here we use like BlueZ audio for the audio handling. This work is like ongoing work for BlueZ 5. There is a couple of patches on the BlueZ audio main list that is re-implementing the whole Bluetooth support in BlueZ audio for A2DP, HFP, and yeah, A2DP and HFP. We only support the SBC codec, which is mandatory by the specification, and the MPEG codec is still not supported. We should come up with this at some point. I'm not sure. I don't. Do you know?
Some phones, the iPhone being better than the others, just to have support for their native format one way or another. Some screw up X. So when it comes to codec support, it really depends on what kind of phone and phone quality you get. Most of them just use SBC and stick with it. Some high-end phones like an iPhone, they have a couple of more codecs supported. The other side is then you need this on both sides to actually make this properly. So SBC is really the only one that is mandatory on the site.
We support. But last time I checked on the code, it was like saying 1.2. Yes, because the difference is like nothing. Yeah, exactly. Yeah. I checked that. Yes. So yeah, we support 1.3 because. Next one is AVRCP. It's a profile that we use to control media over Bluetooth, like the commands like play, pause, and then that was like version 1.0. Version 1.2 introduced like metadata, so then you can transfer over Bluetooth who is the artist or who is the album or the track number, many information about the music or the video you are playing. And the 1.5 introduced the new concept of media browsing, so now you can browse the folders and the library on the other Bluetooth device. And in BlueZ, currently we support both holes, but the media browsing is still a work in progress. It's not totally completely. I think Luis has been working on this lately, and it's not a completely work yet. Then we have HFP. HFP is probably the most important profile that BlueZ ever had, and in the automotive world, I think is going to be the most used too. And it basically handles phone calls over Bluetooth and has some fancy features like swap calls or three-way calling. That's pretty nice. And here we use Ophono for the whole call control. And for Ophono, the Bluetooth HFP works like any other modem, and use the normal phone API to handle a Bluetooth phone. It's pretty. If you have implemented something to handle phone, you are handling Bluetooth phones as well. And BlueZ audio, as I said, is going to handle the audio, and it's still a work in progress. We support the wideband speech. That's a feature from the 1.6 version of HFP. It's a better quality audio for HFP. Was introduced in the 310 kernel. We have HSP. It's like the same thing, but quite old, and we can use it mostly for VIP. It's not implemented in BlueZ. Not sure if we really have this use case, but it's something that we can have at some point if it's needed. It's a really simple file, doesn't have any complex call control, doesn't have like two-way calling. It's really, really simple. And some really, really old phones only support HSP. And SPP is like a serial port profile. It emulates serial ports on both sides and both devices that are connected. It mostly use it for proprietary applications. If you want to build something proprietary over Bluetooth, you can like use this. BlueZ just provide like API when you can get like a socket of a serial port, and then you put whatever data when you want on it. The next one is SIM access profile. It's a way to give remote access to your phone SIM card, and the use case you can have in a car is like you have your phone and your car connects to your phone to have access to the SIM card, and the card itself has to have like all the telephony hardware to use the remote SIM card to do phone calls or using mobile data. Is anyone using that? I never seen anyone using it. Yeah, I never seen anyone in the automotive world as well. Usually people do. Yeah. 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 Yeah, I think the only benefit is that you don't need to transfer the Bluetooth data over, like the call data over Bluetooth. You do directly to the cell station. And the support we have is in BlueZ of phone is like for one modem that has built-in SAP. So I don't think anyone is using this. No.
So the thing is, this spec was developed back in the days when we only had feature phones. And once you take a smartphone in your car, you run into a couple of issues. As Daniel mentioned, your SMS go now to your car unit, so they end up in your car and not be on your phone, which doesn't make a lot of sense once you leave the car. With your phone, you don't have the text message. In case you didn't read it, it's just in the car. Same as for your call history. So you called someone, the call history is in your car now, and then you want to call this person back while you're outside the car, your call history is missing. The most important one is if you're gonna do your network connection over 3G, LTE or whatever, once the car owns the SIM card, your phone has no data connection whatsoever anymore. There's a white paper from the Bluetooth SIG released, I think half a year ago, that tries to fix this, where essentially the phone then uses a PAN connection back into the car to get your network connection back. But let's face it, that's a white paper, and I've not heard anybody actually seriously considering implementing this one. So the profile is great if you want to use your car antenna that is outside your car, because you finally can use that properly. The reality is, with smartphones, it's so complicated to get this right that some companies and some phone manufacturers said, we are giving up on it. And this is where the real problem comes from. So I think someone thinks like inductive antenna or whatever they came up with is something more to solve the problem, to get the radiation of the GSM cellular part out of the car to the car antenna. But reality of the fact is HFP is the one solution to deal with these ones and not SUB anymore.
Yep. And then PAN is basically share internet connection over Bluetooth. And we support Truth Command and BlueZ, both holes. Like you can share a connection or can get a connection from some device. And the last version is 1.2 and BlueZ support both of them. And we have as well the dial-up network as a try to mimic a dial-up modem over Bluetooth. It's an old specification from the Bluetooth SIG, and PAN is the new one, and works much better. But we have some old phones that only support DUN. I think the Nokia Symbian only supports DUN, and some other phones.
So yeah, I've implemented that part. So when we have discussed that problem, what happens if you have a phone which supports both profile at the same time? So where do you do the selection? And we ended up discussing forth and back, and currently we have not solved it, right? We just expose it to the user space, PAN and DAN at the same time. And we have no clue how to identify if the network belongs, if PAN and DAN network belongs to the same device. So I'm still trying to figure out how we want to solve that, or we just say, okay, DAN dies and we do not care. Just recreate. So we do not. Okay. For the record, it's deprecated.
Let's forget about it then. So yeah, it should be using PAN and not DUN. And another important profile is phonebook access, and it basically access contacts over Bluetooth. And we implement the latest version, but the profile is like not really good for the use case in the car, because every time you connect to the phone, we have to download all the contacts again, or there is like no way to sync. You can keep the contacts, but if you want to sync, there is like no way. I'm not sure if the Bluetooth 6 work on something on this right now, but it's really something that we need, because otherwise, every time you go to your car and you want to sync like new contacts you added, you need to do a whole download of the contacts. And map is a really nice one too. You can like access email and SMS, and not only access but read and update, write emails and SMS over Bluetooth. It's really a nice one. The latest spec version is 1.2, and BlueZ we still have the 1.0 last time I checked. And OPP is a very famous one. It's basically for transfer files. I'm not sure if this will be really useful in cars, but we support both holes in the latest specification version. And there is a new profile introduced by the Bluetooth SIG, I think last year, I don't know. It's the global navigation satellite system profile. It's basically you can share your GPS device with another device over Bluetooth. And it uses like the standard EMEA protocol. And it needs to be handled by some GPS application, because BlueZ doesn't really talk this protocol. We'll basically handle a file descriptor to some application that wants to handle this. So we can say that we have kind of support for this. We just need some GPS application to handle the EMEA protocol and get localization. And another thing that could be useful in cars is high speed. And it's basically a way to transport Bluetooth data over the Wi-Fi radio. And if your system needs like more bandwidth, you can like transparently move to another radio and go from Bluetooth to Wi-Fi and get a much higher transfer bandwidth. It's like completely abstracted for the user. It goes automatically if you set the proper sets in the kernel. And that's a good thing to do if you need more bandwidth. Not sure if it's going to be really used in cars. Depends on the automakers. And we only support full Mac in Linux. Any profile that runs over L2CAP. It's transparent. You just need to set some configurations in the kernel.
So could I have a network?
Yes. It makes sense.
Yeah, that's
Yeah.
okay.
John?
Is anyone working on Mac with the 11 integration for this?
I don't know anyone. Do you know, Marcel?
I don't know anybody working on this.
Was Johannes looking at this at one point?
Well, it says it only takes a week or two.
Well, he never gets to it.
They like got a week or two.
How do we make him get to it?
You sit it down, time to share, wasn't good. Maybe that works.
Okay.
Okay. And the thing I think is the most important right now for BlueZ is testing. We have support for many profiles. They are kind of in a good shape. But Bluetooth products usually need lots and lots of testing to be compatible with the many devices that are out there. And BlueZ was like initially focused on mobile, which is basically the other side of the use case. And Automotive is like a new vertical. So we still don't have that many testing on this side. One of the ideas is like create new test frameworks for BlueZ, some piece of codes that can handle many tests automatically, and try to publish this and show people everywhere that BlueZ actually works for the automotive world. No, I started some code on this, but only a week of code, like last week. I don't have anything really working right now. But it is one of the ideas. I'm not sure which things I'm going to implement, or yeah, it's something really new. And some conclusion. BlueZ, of course, is open source for people that wants to put it in a car. You can like share your development costs and maintenance costs, and of course you can choose whatever company to get support. Collabora is one of those companies, and we don't have any license fees, of course. Well, that's it. It was quick. Thank you all. Any more questions? Okay, thank you.